Welcome to Lesson 6.5. Today we're going to talk volume of cylinders. Our learning objectives: being able to recognize volume of cylinders as the sum of the volumes of layers of unit cubes. You will find volumes of cylinders using formulas. You will find heights of cylinders given volumes and other dimensions. You will solve real-world problems involving volumes of cylinders. Here's our introductory problem. Pause the video, read through that before moving on. In this lesson, we will learn to find the volume of cylinders. A cylinder is a solid shape that exists in three-dimensional space. A cylinder has two faces that are circles. We do not call the side of the cylinder a face because it's curved. We still have to include its area in the total volume of the cylinder, however. We see cylinders in everyday life all the time. Here's a basic shape of a cylinder. Think about how many other places you can see them in the world around you. The volume of a cylinder is the measure of how much three-dimensional space it takes up or holds. Imagine a thermos. Its size determines how much water the thermos will hold. If we fill it with water, the amount of water tells the volume of the thermos. We measure volume in cubic units because we are multiplying three dimensions: length, width, and height. The width of the thermos is the same as the diameter of the circular faces. There are different ways to examine and think about volume. One way is to use unit cubes. Look at this diagram of the cylinder to understand this concept. Here you see that the unit cubes are being used to fill up the cylinder. Remember that because we are talking about volume, we are measuring the space contained inside the cylinder. This can be tricky with a cylinder because the bases are round squares, or bases are round. Squares aren't exactly round. So we should find another way to measure the volume of a cylinder. So let's think about what information we're going to need to gather to figure out the volume of a cylinder. We know that the two bases are circular, so we're going to need to know the area of a circle to figure out how much space can be contained on top of it. The cylinder is tall or has a height, so we're going to need to know the height of the cylinder. Then we will need to know how high the space is inside the cylinder. First, let's think about the area of the circular bases. To find the area of a circle, we can use the following formula: A is equal to pi r squared. We talked about that back in 6.2. But we also have the height of the cylinder to figure out into this calculation. So if we put all of those parts together, we have the following formula for the volume. It's pi r squared h. So we take pi, which we'll use as 3.14, times our radius squared. Remember, squaring means we multiply it by itself, times our height. So we're going to multiply all those parts together. So if we have a cylinder that has a radius of 5 centimeters and a height of 7, and we're asked to find the volume, 5 goes in for R, 7 goes in for H. And again, we're going to use 3.14 for pi, so we're going to have 3.14 times 5 squared times 7. Remember, 5 squared is the same as 5 times 5. If I type that in, I get 25, so I'm going to do 3.14 times 25 times 7. And that's going to give me my volume, which is 549.5, and our label is centimeters, so we're going to have cubic centimeters. So now we have a cylinder with a diameter of 12 inches and a height of 8. Now we are given the diameter, but we're using radius. So if we are given diameter, remember radius is half of that. So half of 12, we're going to use 6 for our radius. So we'll put that in for R. 8 is our height. It's going to go in for H. So we're going to have 3.14 times 6 squared times 8. 6 squared again is 6 times 6, which is 36. So my equation is going to be 3.14 times 36 times 8, giving me a volume of 904.32 cubic inches. Go ahead and pause the video and find the volume of all three cylinders using the formula on the top, and then hit play and see how you did. For the first one, you should have put 3 in for R and 7 in for H, giving you 3.14 times 3 squared times 7. 3 squared is 9, so 3.14 times 9 times 7 should give you a volume of 197.82 cubic inches. For the second one, you should have put 2.5 in for R and 4 in for H. 2.5 squared is 6.25. So you should have done 3.14 times 6.25 times 4, giving you a volume of 78.5 cubic millimeters. For the last one, you should have put 7 in for R because you were given a diameter of 14, and 9 in for H, so 7 squared is 49, so you should have done 3.14 times 49 times 9, giving you a volume of 1384.74 cubic inches. Sometimes you will know the volume of a cylinder and you won't know the height. Think about a water tower that is cylindrical in shape. We might know how much volume a tank can hold, but not the height of it. When this happens, we can still use our formula to find the missing height of the cylinder. So for our example here, we've got a cylinder with a radius of 2 inches, has a volume of 125.6 cubic inches. They want to know the height. So my radius is 2, so 2 is still going to go in for R, and our volume is 125.6, so that's going to go in over here. I'm still going to use 3.14 for pi, times 2 squared times h. 2 squared, again, is just 2 times 2, which is going to get me 4. So I'm going to have 3.14 times 4 times h. I can multiply the two numbers that I know, so 3.14 times 4 gives me 12.56. And then from here, this turns into a one-step equation where I'm multiplying on the right here. So to undo that, I divide. So I'm going to divide both sides by 12.56. And when I do that, I get that my height is 10. And since we have inches as our label, it'll be 10 inches for a height. So for our next one, we've got a cylinder that's got a radius of 6 centimeters and a volume of 904.32 cubic centimeters. So again, our radius is 6, so 6 is going to go in for R. Our volume of 904.32 is going to go in for V. Oops, 904.32. Still going to use 3.14 for pi. Okay, again, 6 squared is just 6 times 6. So 6 times 6 is 36. So on the right, I'm going to have 3.14 times 36 times h. I multiply together the two numbers that I know, and that gives me 113.04 times h. And again, single step equation from here, divide both sides by what's in front of h. And that's going to get me a height of 8. And our label is centimeters, so our height is 8 centimeters. Go ahead and pause the video and find the height of these 3 cylinders with the given radius and volume using the formula on the top, and then hit play and see how you did. So for our first one, if you check your work through there, we should have gotten a height of 10 feet. For the second one, we should have gotten a height of 9 meters. And for the third one, we should have gotten a height of 8 inches. And again, make sure you pause, check all of your work first before moving on. So we can also use what we have learned to find the volume of cylinders that we use in real life. Be sure you understand what the problem is asking. Then look to see what information is given in the problem. Third, put this information in for the appropriate variable in the formula and solve. So let's give that a try. So a water tank has a radius of 50 feet and a height of 40 feet. How many cubic feet of water will the tank hold when it's full? So we're given a radius, so we're going to plug that in for R, and a height, we're going to plug that in for H. We are solving for V, because that's cubic feet. So we're going to use 3.14 for pi, just like we always do. I'm going to take 50 and square it, and times it by 400. Remember, 50 squared is just 50 times 50. And if I type that in to my calculator, 50 times 50 gives me 2,500. So now I type this into my calculator as I see it, 3.14 times 2,500 times 400. I get a volume of 3,140,000 cubic feet. That is my volume of this water tank. So Javier wants to construct a cylindrical container to hold enough water for his pet fish. He read that the fish needs to live in 2,110.08 cubic inches of water. If he constructs a tank with a diameter of 16 inches, how tall must he make it so that it holds the right amount of water? So when they give you a number with cubic after it, that's going to go in for V. So my 2110.08 is going to go in for V. I use 3.14 for pi. I'm given a diameter of 16 inches. Well, I need radius from that. So if the diameter is 16, the radius is half of that. So 8. 8 will go in for R. So I'm solving for H. Well, first of all, 8 squared, which again is 8 times 8. That gives me 64. I can multiply 3.14 and 64 together, and that'll get me 200.96. And then to solve for h, I divide both sides by that 200.96. And if I do that, I get an answer of 10.5, and my label is inches. So I would need it to be 10.5 inches tall. Just a reminder of the introductory problem at the beginning. Make sure to pause the video and read through this again before moving on. Here's the solution to the problem, so make sure again you pause the video before moving on. So to review, volume is the capacity something can hold. The formula for the volume of a cylinder is V is equal to pi r squared h. Okay? Need to have that equation written down somewhere. The volume of a cylinder is the measure of how much three-dimensional space it takes up or holds. We measure volume in cubic units because we are multiplying three dimensions, length, width, and height. And a cylinder is a solid figure that exists in three-dimensional space.